Bismillahirrahmanirrahim. Dear students, welcome you all to the industrial pharmacy class. As you know, today is the new chapter. So far, we have discussed in this semester mass transfer, as well as we have completed the second chapter, that is heat transfer. In heat transfer, we have discussed the different types of heat transfer, including conduction, convection, and radiation. Pharmaceutical application of heat transfer, and we have discussed in detail the example of conduction by explanation of conduction with example of laboratory water bath, and we have also explained in heat transfer chapter the steam, the production of steam, the heat content of steam, and reason behind the use of steam in the pharmaceutical industry, and at the end of heat transfer chapter we have discussed the installation, that is the steam jacketed installation used for the manufacturing of the liquid and semi-solid dosage form. And today we are going to start the new chapter, that is drying, that is the third chapter in our syllabus, that is drying. And today's lecture we will discuss the general introduction and the pharmaceutical applications of drying. Dear students, the main focus is to learn about the drying and its pharmaceutical application, the pharmaceutical significance of the drying. Dear students, after the completion of this lecture, you will be able to learn about the general introduction of the drying and its pharmaceutical application. Let's start that from the introduction of drying. That what is meant by drying? The drying can be defined by different ways. The first one is we can define drying as the removal of small amounts of water or other liquid from a material by the application of heat. That is the simplest definition of the drying, that is removing a small quantity of solvents, that may be water or any other liquid, and it is termed as drying. It also includes the removal of volatile liquids or water from another liquid or gas or a suspension. If we have a liquid and we are going to remove any other liquid, that may be water or any other liquid that is volatile in nature, and we are removing that, that is also termed as drying. Or if we have a gaseous material and we are going to remove the volatile liquids are aqueous solvents. In that case, we also termed it as drying. Or if we have suspension and there is some quantity of volatile ingredients or volatile liquid or aqueous solvents, and we are going to remove it from that particular suspension, and that is also termed as drying. So it is clear from the definition that not only the removal of small quantity of aqueous solvent, that is water, or it may be any other liquid, it may be volatile liquid or any other liquid. If we are removing that particular solvent, that may be water or any other liquid, we will term it as drying. Drying is a common unit operation that is used to reduce the levels of water or organic solvents and pharmaceutical material to the acceptable level, to the desired level, to the limited level that is acceptable for that particular preparation or particular pharmaceutical material. In order to obtain that acceptable range or levels of the particular water content or organic solvent and that particular material, for that purpose drying is commonly used unit operation. In general terms, drying can be described by three processes operating simultaneously. If we are describing the drying process, then there are three processing that is simultaneously operating. The first process is energy transfer, that is from an external source to the water or organic solvent and that particular material which you want to remove the small quantity from that material. Then the first process is energy transfer, that may be from external source to the water or the solvent that is to be removed from the material. And the second process is the phase transformation of water or organic solvent from a liquid or liquid-like state to the vapor state. And the first phase or the first process, that is the energy transfer, and the second phase, that is the water that is to be removed or organic solvent that is removed from a liquid or liquid-like state or from a material to a vapor state. That is the second process. And the third process, that is the transfer of vapor generated away from the pharmaceutical material and out of the drying equipment. Now it is clear that the drying process can be described by these three processes that are operating simultaneously. That the first process is the energy transfer, the second process is phase transformation, that is the water is or organic solvents to be removed from that particular material, which may be from the liquid or liquid-like state or from the solid material. And the second process involving the phase transformation of water or organic solvent that is to be removed and that is converted to vapor state. And in the first step, that is the vapor that is already converted in the second step, that is generated in the second step in the form of vapor that is to be removed from the pharmaceutical material and out of the drying equipment. Out of the drying equipment means out of the dryer that is used for drying purposes. The product obtained from an evaporator is either concentrated solution, suspension, or a wet slurry, whereas that from a dryer is substantially dry solid. If we removed a material from an evaporator, this will be either in the form of the concentrated solution or suspensions or a wet slurry, whereas if we removed the product from the dryer, that will be substantially in the form of dry solid. The process of evaporation involves removal of much more quantity of liquid per hour than and drying. It means that in evaporation, the large quantity of material or the liquid, that may be water or any other solvents, that may be organic solvents or the volatile solvents, that is much more quantity per hour compared to if we have to remove the quantity of liquid and drying. Now we will discuss the methods of drying. There are two main categories of drying. The first one is thermal drying, that is using by the application of heat, and the second one is non-thermal drying. For example, that is freeze drying where heat is not applied. And non-thermal drying processes include expression, that is expression of solid to remove liquid. For example, if we squeeze a wetted sponge, and that particular squeezing process of wetting sponge, if we express the solid, right, to remove the liquid. And the second one, the wetted solid, that is wetted sponge. If we squeeze it, and by the process of expression, it is a non-thermal way of drying, the solvent is removed or the liquid is removed. The second one is extraction. The example of non-thermal drying is extraction, the extraction of liquid from solid by use of solvent, and different extraction processes of the extraction of the material or the liquid is removed by use of solvents. The third example of non-thermal way of drying is adsorption by use of desiccants such as anhydrous calcium chloride. That is one of the example of desiccant to remove the moisture. Absorption, the absorption of moisture from gases by passage through a sulfuric acid column, that is another example. Desiccation of moisture from a solid by placing it in a sealed container with a moisture removing material, that is silica gel and bottle. If you have seen in the tablet bottle or capsule bottle, silica gel is kept for removing the moisture content. It is one of the desiccant. It is silica gel for moisture removing from the container or the bottle. Now in this part of the lecture, we will discuss the pharmaceutical applications of drying. There are different pharmaceutical operations, including those used to produce active pharmaceutical ingredients, that is API, that is responsible for the therapeutic effectiveness or activity, and some of the excipients, that is other than the active pharmaceutical ingredients are additives. We use water or organic solvent as essential processing aids. Essential processing aids, liquid solvents or inorganic solvents or volatile solvents are used for the processing of the active pharmaceutical ingredient for the excipient processing. We use either water or organic solvents or volatile solvents as essential processing aid. The drying rate can be impacted by the properties, the functionalities, and quality of the material being dried. If we consider the rate of drying, then there are different factors which may include the impact of the properties of the material and their functionality and the quality of material that we are going to be dry. Some of the applications of the drying include preparation of bulk drugs. And the preparation of bulk drugs, drying is the final stage of processing. For example, dried aluminum hydroxide. If we are preparing or processing dried aluminum hydroxide, the drying is the final stage for the processing of manufacturing of the dried aluminum hydroxide. Spray dried lactose. If we are desirous to prepare spray dried lactose, for this purpose the drying is the final stage. Powdered extracts. If we are extracting material and in the form of the powder. For this purpose, the drying is the final stage. And the preparation of butters like dried aluminum oxide, spread dried lactose, and powder extract, it is essential part of the final stage. The final stage, that is drying. The second pharmaceutical application is the preservation of drug products. Drying is necessary to avoid deterioration in order to enhance stability. For example, crude drugs of animal and vegetable origin, synthetic and semi-synthetic drugs like aspirin and penicillin tablets that undergo chemical decomposition processes, but if we formulate it in the form of dried form, in this case the crude drugs of the animal origin or vegetable origin are synthetic and semi-synthetic drugs, and for example aspirin and penicillin tablets that is undergo the chemical decomposition processes, but in case of the dried form they are lacking the chemical decomposition processes. Like the effervescent tablets, if you see or effervescent granules in the form of dried form, they are not undergoing the chemical decomposition processes. So in the dried form, the preservation of the drug is possible, including the crude drugs of animal and vegetable origin, aspirin, that is effervescent tablets of aspirin, and penicillin tablets are uh, inosocial, that is in the form of the dried form, they are not deteriorated or decomposed. And certain other examples, including the blood products, skin and tissue that undergo microbial decomposition. So, drying is necessary to avoid deterioration of these products. Improved characteristic is one of the prominent application of the drying. As you know, drying produces material of spherical shape, uniform size, free-flowing, and enhanced solubility. For example, granules are dried to improve the fluidity, that is the flow properties and compression characteristic. If we dry the granules, they can be easily flow and their flow properties will be enhanced, and their compression and to the form of tablets will be also more compared to if they are not in the dried form. And moreover, granules in the dry form can be easily compressed, and they are not stuck with the die and punches, and the flow from the hopper and the compression machine, or if we are going to pack granules as such in the form of sachet, their flow will be improved if they are dried. Viscous and sticky materials are not free flowing because they are sticking, attaching to the machine parts, and drying modifies these characteristics. Examples are malt corn extract, malt extract, and oleoresin. Improved handling has another applications of the drying. Removal of moisture makes the material light. If we remove the moisture or the liquid, as we know that we have focus in the definition that removal of the moisture, removal of the liquid, or removal of the solvents, that may be organic solvents or any other volatile solvents from the material. If we remove the moisture from the material, then its weight will be definitely low and it become lighter and weight, and reduces the bulk quantity of the material will be also reduced because if we remove the moisture. Thus the cost of transportation, and as you know that the weight will be and the bulk will be also reduced, so the cost of transportation will be less and storage will be efficient. If we have a material that has content of the moisture, and on the other hand, if we have removed the moisture and formed dried, the storage will be efficient for the dried one compared to that having the moisture content. So improved handling will be possible if we remove the moisture and the material is dry. Stability enhancement is one of the important applications of the drying in the pharmaceuticals. Removal of moisture significantly reduces the rate of chemical reaction and the chances of microbial attack or enzymatic actions, and thus improve stability. So by removing the moisture or the liquid that may be volatile solvents or water or any other organic solvents, if we remove the moisture from the material, the chances of the stability will be improved and the chances of the chemical reaction and microbial attack will be minimized. After pharmaceutical applications of drying, let's consider some of the drying of material. If we consider some of the basic consideration for drying a material, if we are going to dry a material, then what are the different factors which we will consider and which will affect the drying process? When considering how to dry material, the following points should be considered. The first one is heat sensitivity of the material being dried, that is heat sensitive, that how much it is heat sensitive and how much heat it is absorbed by the material that is being dried. And the second one is physical characteristic of the material. And the third point which we must consider, that is nature of the liquid to be removed, that is organic one or inorganic one, and whatever the liquid that is fertile one or organic one or water. And the scale of evaporation, that is how much quantity to be dried, and available sources of heat, that is we have steam or electrical, and we have also checked the available sources of the heat to remove the moisture. Now we will discuss in this part the difference between drying and evaporation. Recalling from the points that we have considered in this slide, that I'm going back to the previous slides which we have on the start, that the process of evaporation involves removal of much more quantity of liquid per hour than the in case of the drying. Recalling and connecting with that particular points, in drying process the main operation usually carried out on solid material, for example powders or product, and an evaporation process, the main operation usually carried out on liquid material, for example solvents, that is in solution or products. And the second difference is drying in most of the cases means the removal of relatively small amount of water from solids, and evaporation includes the removal of large quantity of water from the solution. In case of the solutions that is already in solution form, we are going to remove the amount of water or solvents, and quantity will be larger compared to in case of the drying. In most cases of drying involves the removal of water at temperature below its boiling point, whereas an evaporation means the removal of water by boiling a solution, and it is evaporated. The solvent is evaporated from the particular solution. And another difference is in drying, water is usually removed by circulating air over the material in order to carry away the water vapor, while in evaporation water is removed from the material as pure water vapor mixed with other gases. These are the differences between drying and evaporation. The references, you can consult the Encyclopedia of Pharmaceutical Technology Volume 1 3rd edition, pages consulted over there. You can see that is 1425, and the second reference you can consult for this one, that is the Theory and Practice of Industrial Pharmacy by Lackman and Laberman, 3rd edition, pages 47 to 48. These pages may be varied in the latest or in the older edition. And the third one is the Amy Alton Pharmaceutics, the Science of Dosage Form Design, 2nd edition, pages consulted over there 382 383. Thank you all for your attention. An overview of the today lecture. Let's overview on the lecture. Today's topic was drawing, a general introduction of pharmaceutical applications. And first of all, we have defined the drawing, that is the removal of small amounts of water or any other liquids from a material by the application of heat. Remember that not only the removal of small amount of water, but it may be also any other liquid, which may be removal of volatile liquid or liquid not only from the material, that may be the solid in nature, it may be water from another liquid, or gas or suspension. The main objective is to keep the acceptable levels of the solvents or the water and that particular material. And we have also discussed that drying can be described by the three processes. The first one is energy transfer, the second one is phase transformation, and the third process, that is the transfer of vapor that is generated and the second phase, and these vapors to be removed from the pharmaceutical material and out of the particular dryer that we have selected for the drying purpose. And then we have discussed the products obtained from the evaporator and the product obtained from a dryer, and the difference between the evaporation and the drying, the quantity and the drying, and then the evaporation of that liquid to be removed. And evaporation, the removal of large amount of liquid per hour compared to the drying. And methods of drying, we have discussed the thermal drying, that is the application of heat, and non-thermal way of drying, that is the way by which we remove the solvents, that is water, which may be any other liquid, but here we use not using the heat. And different example of the non-thermal way of drying, including extraction, absorption, desiccation, and then we have discussed in detail the application of drying, including the preparation of bulk drugs, preservation of drug products, and improved characteristics, improved handling, stability enhancement, we discussed these pharmaceutical applications or objectives of drawing in detail with the suitable example. And after that, we have discussed the consideration for drawing a material, different points including heat sensitivity of the material that is to be dried, and physical characteristic of the material, nature of the liquid to be removed from the material, the scale of evaporation, available sources of heat, either the heat source that is provided by the steam or electrical source available. And these are the points which we discuss one by one. And at the end, we discuss the difference between drying and evaporation. And at last, the references consulted for preparation of this lecture. Thank you all for your attention.